Hello students and good morning. So now I am doing class for class 12. The topic is the new topic, that is binary operation. So in the last online class we finished relation and function. So I think you revise all the problems and all the theory portion that we did in function and relation. So today we will start the new topic, that is binary operation. So what is meant by binary operation now? So you know binary means two. Your binary actually its meaning is two. Binary means two. Operation means, you know the operation. This operation may be plus, it may be minus, it may be multiplication, it may be division. Okay. Now this plus is a type of operation. This minus is a type of operation, multiplication is a type of operation, and this division is a type of operation. So this operation is done on two numbers, like 2 plus 3. That is, this operation is done on two numbers, that is 2 plus 3. It may be this minus sign. This is operated on two numbers, that is 2 minus 3, and this multiplication is also done on two numbers, that is 2 multiplied by 3, and this division is also operated on two numbers, that is 2 divided by 3. So you जुन चाहिँ operations are 2 plus 3, 2 minus 3, 2 multiplied by 3, 2 divided by 3, that is done in lower classes, isn't it? That is you have done it in class KG or 1, 2 or 3, like that. Okay. So now actually we write this one also, 2 plus 3 plus 5. Like in this case, first of all we will add this 2 plus 3. First of all you add 2 plus 3 plus 2 plus 3 is 5, and then plus 5, which is equal to 10. Okay. So this binary means two, and operation means it may be plus, it may be minus, it may be multiplication, it may be division, like that. Okay. So now we'll discuss about what is binary operation now. Okay. Now what is the meaning of binary operation? So now in this case, let us take an example. Suppose R is the set of real numbers. R is the set of real numbers, right? So R is the set of all real numbers. All the defined numbers are included in real numbers. Like rational number is real number, irrational number is also a real number, positive integers, negative integers including 0 are also real numbers. All those rational numbers and irrational numbers are also real numbers. Okay, and all those natural numbers are also defined numbers or real numbers. Okay, so let us take two elements that belong to these real numbers. Okay, let us take A that belongs to the set of real numbers, and let us take B that belongs to the set of real numbers. Okay. So let us take the operation as this star. Let us take the operation as this star. This star may be plus, it may be minus, it may be division, it may be multiplication, and so on. Right? So let us take this operation as a star. So this star is operated on these two elements only. That's why it is known as binary operation. So let us take the two elements A and B that belong to the set of real numbers R. And now this star is operated on these two elements. Suppose this is A star B. So if you take the operation on these two elements, that is A star B, and if that A star B also belongs to the set of real numbers R, then this star is known as the binary operation. So I think I've understood it. So what is a binary operation? So let us take R as the set of real numbers, and let us take two elements, that small a belongs to the real number r, also b belongs to the set of real numbers r. So if you can find out a star b which also belongs to the set of real numbers, then this star is known as what? Binary operation. This star is known as binary operation. So I think you have understood it. So let us take an example. म अर्को example दिँदैछु अब. Suppose again R is the set of real numbers, right? R is the set of real numbers. All those defined numbers belong to the set of real numbers. Okay, so you know that 2 by 3 belongs to the real number. Is that clear? And 1/3 also belongs to the real number r, right? So what is their summation? Let us take the operation addition. So 2 plus 3, in this case this star is taken as what? Plus. Okay, in this case this star is taken as plus. So 2 by 3 plus 1 by 3, what is it? 2 by 3 plus 1 by 3 is 3 by 3, which is equal to 1. 1 also belongs to the set of real numbers. That means this star is binary operation on the set of real numbers. So I think you have understood it. Okay, so let us take the two numbers 2 by 3 and 1 by 3 which belong to the set of real numbers, and let us take the operation as plus sign. So 2 by 3 plus 1 by 3 is equal to 3 by 3, which is equal to 1. That also belongs to the set of real numbers. So this plus, which is the addition, that is a binary operation. This plus is known as what? This plus is a binary operation on the set of real numbers. So I think you have understood it. So let us take now next example. Let Z be the set of integers. Let Z be the set of integers, right? Let Z be the set of integers. So let us take two elements A and B that belong to the set of integers. Okay, so what can we say about A plus B? That A plus B also belongs to the set of integers. So in this case the star operation is taken as plus sign, addition. So A plus B also belongs to the set of integers, isn't it? You know that 3 belongs to the set of integers, and also -4 belongs to the set of integers. So let us add them. 3 plus within bracket -4 is equal to 3 minus 4, which is equal to -1, also belongs to the set of integers. That means this plus sign is a binary operation on the set of integers. Is that clear now? So let us take another example. Let capital N be the set of natural numbers. Let capital N be the set of natural numbers. Okay, so let us take two elements A and B which belong to the set of natural numbers. A belongs to N and B belongs to N. Okay, so their addition. So A plus B, what can I say about their addition? A plus B also belongs to the set of natural numbers, isn't it? Like example, you know that 2 belongs to natural number, 3 belongs to natural number. So their addition 2 plus 3 is equal to 5, also belongs to the set of natural number. That means this plus sign, this plus is binary operation on the set of natural numbers. So I think you have understood it. What is binary operation? Next example. So not only plus, you can take minus, multiplication, division, etc. Okay. So let us take another example. Let n be the set of natural numbers and A belongs to the natural number, B belongs to the natural number. Can you say that A minus B belongs to the set of natural numbers? Can you say that A minus B belongs to the set of natural numbers? So let us take an example. Okay, you know that 4 belongs to the set of natural numbers and 10 belongs to the set of natural number. Their subtraction, that is 4 minus 10 is equal to, what is it? Minus 6, does not belong to the set of natural number. Natural number means it starts from the positive number, that is positive 1, positive 2. It should be all positive integers. That is known as natural numbers. Is that clear now? So this A minus B does not belong to the set of natural number. That is, this subtraction is not a binary operation on the set of natural numbers. This subtraction operation is not a binary operation on the set of natural numbers. तो यो जुन चाहिँ माइनस साइन छ, तो यो माइनस साइन चाहिँ बाइनरी अपरेसन होइन, केमा हैन, अन द सेट अफ नेचुरल नम्बर्स. तर रियल नम्बर्समा चाहिँ हुन्छ नि फेरि यो. रियल नम्बर्समा कसरी हो भन्दा फेरि जस्तै अब एक्जाम्पल, let R be the set of real numbers. R be the set of what? Real numbers. Okay. So let us take two elements that belong to the set of real numbers. A belongs to R, B belongs to R. Okay. So their subtraction, A minus B, also belongs to the set of real numbers. So if you take 2 belongs to real number and 5 belongs to real number. So therefore 2 minus 5 is equal to minus 3 also belong to the set of real numbers. That means this subtraction operation is binary operation on the set of real numbers. So I think you have understood it. Okay. So next example. Suppose n is the set of natural numbers. N is the set of what? Natural numbers. Suppose n is the set of natural numbers, and let us take two elements as A belongs to the natural number n, B belongs to the set of natural number. So let us find out their multiplication product. So A into B. So if A belongs to the set of natural numbers and B belongs to the set of natural numbers, so A into B also belongs to the set of natural numbers, isn't it? That is, you know that 10 belongs to the set of natural numbers and 11 belongs to the set of natural numbers. So their product 10 into 11 is equal to 110 also belongs to the set of natural numbers. So this multiplication operation is binary operation on the set of natural numbers. So I think you have understood it. Okay. So next example, let us take the division now. Let us take the division. Suppose n is the set of natural numbers, and suppose small a belongs to the set of natural numbers and small b belongs to the set of natural numbers. So can you say that A by B, does it belong to the set of natural numbers? Can you say that if A belongs to the set of natural numbers and B belongs to the set of natural numbers, so can you say that A by B belongs to the set of natural numbers? Let us take an example. You know that 2 belongs to the set of natural numbers and 3 belongs to the set of natural number, but their division 2 by 3, is it a natural number? No, it does not belong to the set of natural number. So this division operation is not binary operation on the set of natural numbers. तर यसमा if you take R as the set of real numbers, if you take R as the set of real numbers, If we take R as a set of real numbers, and suppose R is the set of real numbers, and let us take two elements. Small a belongs to the set of real numbers, small b belongs to the set of real numbers. Can you say that a by b belongs to the set of real numbers? Yes, of course. So let us take an example. 2 belongs to real number. Here 2 belongs to real numbers R, and 3 belongs to real number R. So naturally their division 2 by 3 also belongs to the set of real numbers. So division operation, that is this division operation is binary operation on the set of real numbers. So I think you have understood it, what is a binary operation. So let us write down the definition of binary operation. Okay. How will you define this binary operation? So let us write down the binary operation. Let us take S as a non-empty set. The U S a एउटा general set हो. Let S be a non-empty set. The U S set चाहिँ तिमीहरुको natural numbers को set पनि हुन सक्छ. It may be set of natural numbers, it may be set of real numbers, it may be set of integers, it may be set of positive integers, it may be set of negative integers, it may be set of rational numbers, and so on. Okay, so an operation star an operation star an operation star on a non-empty set S is said to be a binary operation if A star B belongs to the set S for all this A comma B belong to the set S. So this is the definition of binary operation. त अघि नै मैले यो डेफिनेसन लेखेमा तिमीलाई बुझ्न एकदमै अप्ठ्यारो पर्ने थियो हैन. त मैले एक्जाम्पल दिए तिमीलाई यो भन्दा अगाडि. त यो भन्दा अगाडि जुन चाहिँ एक्जाम्पल दिएको छु त्यसलाई तिमीले हेर्नु, फेरि त्यसलाई रिपिट गर्नु. मैले के भन्नु खोजेको त्यहाँ तिमीले बुझ्न सक्छौ. ठीक छ. त त्यो बुझेपछि यो डेफिनेसन क्लियर भइहाल्छ. Okay, so you can understand this definition after seeing that example. Okay, so here the definition of binary operation is that an operation star on a non-empty set is said to be a binary operation if A star B belongs to set S for all A comma B belongs to set S. Is that clear? So this is the definition of binary operation. Okay, so I think you have understood it. You can copy it. So now we will write down the commutative property for this star operation. Okay, what do you mean by commutative law? What do you mean by associative law? Now we'll write down that definition. Okay, so now commutative law. So what is commutative law on star operation? Okay, so let us write down the definition first. Commutative law means if A star B is equal to B star A, then it is commutative. Okay, commutative law means if A star B is equal to B star A, that is known as commutative property. Okay, so let us write down the definition. An operation star, an operation star on a non-empty set S is said to be commutative, is said to be commutative, COMMUTATIV. An operation star on a non-empty set S is said to be commutative if A star B is equal to B star A for all what? A comma B belongs to the set S. So this is the definition of commutative law or commutative property. Okay, an operation star on a non-empty set S is said to be commutative if A star B is equal to B star A for all A comma B belongs to the set S. So I think you have understood it. So let us take an example now. अब हामी यसको example गर्नेछौं. So you can copy it. So let us take an example of commutative property. Suppose capital N is the set of natural numbers. Set of natural numbers. Okay, you know that addition, you know that this plus sign is a binary operation on the set of natural numbers. You know that, isn't it? Right? So can you say that A plus B is equal to B plus A? Can you say that A plus B is equal to B plus A? Yes, you can say that, because you know that 2 belongs to the set of natural numbers and 3 also belongs to the set of natural numbers. Okay? So can you write 2 plus 3 is equal to 3 plus 2? Yes, this is 5 is equal to 5. That means 5 is equal to 5. So this plus is a binary operation which satisfies commutative property. Is that clear? So next what about this subtraction? So what can you say about this subtraction? This subtraction is not a binary operation. This subtraction is not a binary operation, and it does not satisfy commutative property also, because A minus B, suppose R is the set of let us take R is the set of real numbers. Suppose R is the set of real numbers. And you know that A belongs to the set of real numbers and B belongs to the set of real numbers. So in order to check the commutative property, first of all, that operation should be a binary operation. Okay? In order to check commutative property and associative property, that operation should belong to the binary operation first. Okay? So this subtraction on the set of natural numbers is not a binary operation, but that subtraction on the set of real numbers is a binary operation. You know that. I just gave you some example, isn't it? So R is the set of real numbers here. So A belongs to the set of real numbers and B belongs to the set of real numbers. And you know that this A minus B also belongs to the set of real numbers. That is, this minus sign, this subtraction operation is a binary operation on the set of real numbers. Okay? But can you say that it is a commutative property? Does it satisfy commutative property? Let us check it. So A minus B is not equal to B minus A. as you know that 3 belongs to real number and 2 belongs to real number. Okay, what is 3 minus 2? 3 minus 2 is equal to 1, but is 2 minus 3 is equal to 1? No, this is equal to minus. This is equal to minus 1. So 3 minus 2 not equal to 2 minus 3. So this subtraction operation is a binary operation, but it does not satisfy your commutative property. Okay, so I think you have understood it. Okay, next example. So next example for commutative law is, suppose n is the set of natural numbers. Suppose n is the set of natural numbers, and you know that division operation is a binary operation on the set of natural numbers. You know that, isn't it? So A belongs to the set of natural numbers and B belongs to the set of natural numbers. So A into B also belongs to the set of natural number. So can you say that this this multiplication operation satisfies commutative law? So A into B is equal to B into A. You can write it, isn't it? That is A multiplied by B is equal to B multiplied by A. Like you know that 2 belongs to 3, 2 belongs to the set of real numbers, natural number. 2 belongs to the set of natural numbers and 3 belongs to the set of natural numbers. So 2 into 3 is equal to 3 into 2. Obviously, that is 2 into 3 is 6, which is equal to 3 into 2, that is also 6. So I think you have understood it. So this multiplication operation is commutative property. Okay, so it satisfies commutative property. This multiplication operation satisfies commutative property. Okay, as a next one, suppose R is the set of real numbers. R is the set of real numbers. Suppose R is the set of real numbers. Okay, so now you know that A belongs to the set of real numbers and B belongs to the set of real numbers. R is the set of real numbers and A belongs to the set of real numbers and B also belongs to the set of real numbers. Okay, now A into B also belongs to the set of real numbers. A into B also belong to the set of real numbers. Okay, now can you say that A into B is equal to B into A? Yes, of course. In this case also, since R is the set of real numbers, A into B. Suppose if you take A is equal to 2 by 3 and B is equal to 7 upon 8. B is equal to 7 upon 8. This A belongs to the set of real numbers and also B belongs to the set of real numbers. So what is A into B here? 2 into 3 is 2 by 3 into 7 by 8 is equal to 7 by 8 into 2 by 3. That is 2 ones are 2, 2 fours are 8. Here also 2 ones are 2, 2 fours are 8. That is, which implies that 7 by 4 threes are 12 is equal to, this is also 7 by 4 threes are 12. So that means they are equal. That is, this multiplication operation satisfies commutative property. So I think you have understood it. Okay, so let us take another example. So यो examples चाहिँ तिमीले राम्रोसँग बुझ्नु मात्रै, बुझ्यौ? अहिले खाली हेर्ने मात्रै यो एक्जाम्पलहरु चाहिँ, यो डेफिनेसन चाहिँ you can copy it. So यो जुन चाहिँ example छ, try to understand it. Okay, suppose R is the set of real numbers. Okay, now suppose A star B is equal to A by B. A star B is equal to A by B. And all these A comma B belongs to the real number. Okay, so A belongs to real number, B belongs to real number. So this A by B also belongs to the set of real numbers. Okay, so this star is a binary operation. So can you say that this star binary operation satisfies commutative property? Can you say that this star operation satisfies commutative property? So A star B is equal to A by B. What is B star A? For commutative property, this condition should be satisfied, that is A star B is equal to B star A. So B star A is equal to B by A. So are they equal? A by B is equal to B by A. Can you say that A by B is equal to B by A? No, obviously not. So if you take A is equal to 2 and B is equal to 3. Okay, so what is A star B? A star B is equal to A by B is equal to, what is A out here? A is 2 divided by B is 3. So now let us find out B star A. So B star A is equal to B by A is equal to, what is B by A now? This is 3 by 2. So are they equal out here? 2 by 3 is not equal to 3 by 2. So that means A star B not equal to B star A. That means this division operation does not satisfy commutative property. Is that clear now? So what is the definition of commutative law or commutative property? An operation star on a non-empty S, on a non-empty set. You can write here set on a non-empty set. Okay, an operation star on a non-empty set S is said to be commutative if A star B is equal to B star A for all A comma B belongs to the set S. So that is the definition of commutative law. So I think you have copied this definition. So now let us do associative law. Now associative law So what is meant by associative law? So associative law is this type of A star B bracket close star C is equal to A star within bracket B star C. अब यहाँ चाहिँ पहिला ब्रैकेट केमा छ A र B मा छ C मा छैन. अब यहाँ केमा B र C मा हुन्छ A मा हुँदैन. This type of property is known as associative property or associative law. Okay? Now let us write down the definition of associative law. An operation star on a non-empty set an operation star on a non-empty set an operation star on a non-empty set S is said to be associative is said to be associative is said to be associative. An operation star on a non-empty set S is said to be associative if A star B star C is equal to this one A star within bracket B star C for all A comma B comma C belongs to the set S. So this is your associative law. So I think you have understood it. So let us give some example. So let us write down some examples here. So what is associative law? An operation star on a non-empty set S is said to be associative if within bracket A star B star C is equal to A star within bracket B star C for all A comma B comma C belongs to the set S. So let us give some examples now. So now let us take one example. You know that on a set of real numbers, plus operation is a binary operation. Okay? So suppose R is the set of real numbers. R is the set of real numbers. R is the set of real numbers. Okay? Now, can you say that addition is associative? A plus B plus C is equal to A plus within bracket B plus C. Can you say that within bracket A plus B plus C is equal to A plus within bracket B plus C? Yes, obviously it is so. So A plus B plus C is equal to A plus B plus C. You bracket खोल्दै पनि हाम्रो यो left side or right side के हुन्छ? Equal भइहाल्छ. So this addition operation is associative. Is that clear? So you can take the example, you know that A is equal to 4, B is equal to 3 and C is equal to 2. Right? So let us put it out here. A भनेको 4 छ, B भनेको 3 छ, bracket close, plus 2 is equal to. Next, what is A here? It is 4 plus within bracket. What is B plus C? It is 3 plus 2 here. So which implies that 4 plus 3 is 7 plus 2 is equal to 4 plus 3 plus 2 is 5. Which implies that 7 plus 2 is 9 is equal to 4 plus 5 is 9. So this addition operation is associative. So I think you have understood it. Okay. So this is one of the example of associative law. Okay. So now let us take the second example. So let us take the second example now. So second example is subtraction now. Second example is subtraction. Okay. So can you say that A minus B within bracket minus C is equal to A minus within bracket B minus C? Are they equal? So if you open the bracket, this will be your A minus B minus C, which is equal to, if you open this bracket, it will be A minus B minus minus plus C. So can you say that this subtraction operation is associative? Are they equal? No, they are not equal. That means subtraction operation does not satisfy associative law. Okay? So this subtraction operation does not satisfy associative law. So next example, number 3. Suppose R is the set of real numbers. R is the set of real numbers. Suppose R is the set of real numbers. Okay? Suppose R is the set of real numbers. Can you say that multiplication operation is associative? Can you say that A into B into C is equal to A into within bracket B into C? Can you say that? Yes, this is correct. You can give the example A is equal to 4, B is equal to 3, C is equal to 2. These are all real numbers, right? So here, therefore, 4 into 3 into 2 is equal to 4 into within bracket 3 into 2, right? So, or this is 12 into 2, this is 4 into 3 2s are 6, or this 12 2s are 24 is equal to 4 6 are 24. So this multiplication operation is associative. Okay, so this multiplication operation satisfies associative property. So is that clear? So we have discussed about commutative law and associative law. I think you have understood the meaning of associative law and commutative law. So let us do about identity element. What do you mean by identity element? Okay. identity element. So what is the meaning of identity element, right? So suppose if you have, suppose S is the set of, S is a non-empty set. Suppose this S is a non-empty set, and suppose E is an identity element. Suppose E is the identity element that belongs to the set S. Okay, and let us take one element, A belongs to the set S. Okay, let us take the identity element E belongs to the set S, and let us take any element A belongs to the set S. So if you can find out A star E is equal to E star A, that is your commutative, it should be commutative, which should be equal to A. Okay, so let star be a binary operation on a set S. So E is said to be the identity element. E is said to be the identity element if A star E is equal to E star A is equal to A for all A belongs to the set S. Is that clear? That is the definition of identity element. So let us write down the definition of identity element here. Let star be a binary operation, on a non-empty set S. Let star be a binary operation on a non-empty set S. Then an element E belonging to the set S is said to be an identity element, then an element E belongs to the set S is said to be an identity element if A star E is equal to E star A is equal to A for all A belongs to the set S. So this is the definition of identity element. Okay, let star be a binary operation on a non-empty set S. Then an element E belonging to the set S is said to be an identity element if A star E is equal to E star A is equal to A for all A belongs to the set S. Okay, so this is the definition of identity element. Okay, so now let us take an example. So you know that addition is a binary operation on the set of real numbers. Okay, so suppose R is the set of real numbers. R is the set of real numbers. Suppose R is the set of real numbers. So plus operation is binary operation, on the set of real numbers. On the set of real numbers. On the set of real numbers. Okay. Now you know that A belongs to the set real number. A belongs to the set real number. Let us get the identity element of this element A which belongs to the set of real numbers. Let E be the identity element. E belongs to R. Be the identity element. Be the identity element. Okay. Now you know that plus is binary operation on the set of real numbers. So by definition we have, instead of star you can write plus. A plus E is equal to, it is commutative, E plus A should be equal to A by definition, isn't it? So what is the value for E from here? So either you can equate A plus E is equal to A or E plus A is equal to A, that is the same thing, right? So therefore A plus E is equal to A. So here A gets cancels. So E is equal to 0. So 0 is known as the additive identity element. This 0 is known as the additive identity element. This 0 is known as the identity element of the element A that belongs to the real number. That is, A plus 0 will be equal to A. You will get the same number, isn't it? A plus 0 is equal to A, or 0 plus A is equal to, that is also A. So I think you have understood it. So this 0 is known as the additive identity element of the number A that belongs to the set of real numbers. So here 0 is known as additive identity element of A that belongs to the set of real numbers. So this is an example of identity element. Okay, so now the definition is this one. You can copy this definition. So we will do it in problem also. Your identity element हामी problem मा गर्न सक्छौं यस्तो पाराले, ठीक छ? So just try to understand it now. And now let us do multiplication now. You know that multiplication is binary operation on the set of real numbers also. You know that, isn't it? So let us take that example, okay? So next example. Suppose this is an example. Let us find out the multiplicative identity of an element. Okay? So now, you know that R is the set of real numbers. R is the set of real numbers. And you know that this multiplication is binary operation. On the set of real numbers. On the set of real numbers. So this multiplication sign is binary operation on the set of real numbers. So let us take an element. Let A belongs to the set of real numbers. Okay? So now you know that multiplication is binary operation. So let E be the identity element. E be the identity element. E be the identity element. Okay, so now here the binary operation is multiplication sign. A multiplied by E is equal to commutative law. E into A is equal to what? A. So either you can equate A into E is equal to A or E into A is equal to A. So which implies that A into A is equal to A into E is equal to A, which implies that E is equal to A by A, which implies that E is equal to 1. So what is that 1? 1 is the multiplicative identity of an element in case of multiplication. Okay? So here 1 belongs to the set of real numbers, right? So 1 is the multiplicative identity. Multiplicative. So 1 is the multiplicative identity of an element that belongs to the set of real numbers. So I think you have understood it. Okay? So यो example चाहिँ तिमीले बुझी चाहिँ राख्नु एकदमै जरुरी छ. ठीक छ? So I think you have copied this definition. Definition चाहिँ यहाँसम्म हो. So what is the definition of identity element? Let star be a binary operation on a non-empty set S. Then an element E belongs to S, that is set S, is said to be an identity element if A star E is equal to E star A is equal to A for all A belongs to the set S. Is that clear? Now let's do inverse of an element now. Now let's do inverse of an element. So what is meant by inverse of an element? So what is meant by inverse of an element? Suppose S is a non-empty set. फेरि हामी के लियौं? S set लिन्छौं. S is a non-empty set. And suppose an element belongs to the set S. And now we will find out the inverse of the element A. So how can you define the inverse of an element A? Suppose B is the inverse of A. B is the inverse of A. B is the inverse of A if A star B is equal to B star A is equal to E. That is an identity element. You should get, that is, A belongs to the set S. This A belongs to the set S. So B is the inverse of A, and this B also should belong to the set S. And if you can find out A star B is equal to B star A is equal to E, that is your identity element. That is your identity element. Then B is said to be the inverse of A. So in that case, we can write A inverse is equal to B. So I think you have understood it. This is the definition of inverse of an element. Okay. So let us write down the definition. Let star be a binary operation. Be a binary operation on a non-empty set S. Okay. Let small a belongs to the set S. Then B belongs to the set S is said to be inverse of A if A star B is equal to B star A is equal to E, where E is the identity element. E is the identity element, where E is the identity element and E belongs to the set S. Okay, where E is the identity element and E belongs to the set S, and we write and is written as A inverse is equal to B. Okay, so what is the inverse of an element? Let star be a binary operation. Let star be a binary operation on a non-empty set S. Full stop. Let small a belongs to the set S. Then B belongs to the set S is said to be inverse of A if A star B is equal to B star A is equal to E, where E is the identity element and E belongs to the set S and is written as A inverse is equal to B. So that is the definition of inverse of an element. So let us take an example again. Okay. So now you know that 0 is the identity element. 0 is the identity element for addition, isn't it? So example, you know that 0 is the identity element for addition on a set of real numbers, right? You know that 0 is the identity element for addition on a set of real numbers. That is the value of E is equal to 0. So let us find out the inverse of A. Let A belongs to the real number. A belongs to the real number. So let us find out the inverse of A now. So how can you find out the inverse of A? Let B be the inverse of A. Let B be the inverse of A. Okay? So by definition we can write A, here the binary operation start is plus, because 0 is the identity element for addition, isn't it? So we can write here A plus B is equal to, what is E here? A plus B is equal to E is equal to, we can write B plus A, right? So, or A plus B is equal to 0 is equal to B plus A. You know that. So, either A plus B is equal to 0 or B plus A is equal to 0. This is the same equation, right? So, let us write A plus B is equal to 0. Or what is B is equal to? That is your minus A. The minus A is a keba. So, minus A is the inverse of the element A that belongs to the set of real numbers. This minus A also belongs to the set of real numbers. So, यो minus A लाई चाहिँ हामी के भन्छौं? Minus A is known as the inverse of the element A that belongs to the set of real numbers. So, I think you have understood it. So, this is an example of how to find out the inverse of an element. Is that clear? So, now let us take another example. So, I think you have understood it. So let us take another example for how to find out the inverse of an element. Okay. So now you know that for multiplication, 1 is the identity element for multiplication, isn't it? So let us write here. This is another example. So another example is, you know that 1 is the multiplicative identity for multiplication. For multiplication, you know that 1 is the multiplicative identity. Just now we got it for multiplication. 1 is the identity element for multiplication, isn't it? So 1 is the multiplicative identity for multiplication on the set of real numbers. On the set of real numbers. On the set of real numbers. Okay. So now let A belongs to the set of real numbers. Now let us find out the inverse of A. हामी के निकालौं? Inverse of A निकालौं. Let B belongs to real number, be the inverse of A. Be the inverse of A. Now let us find out the value for B. That is, B is the inverse of A. So how can you write it here? So here A is A. Here the operation is multiplication. And here B is the inverse of A. Let us write B. A into B is equal to B into A is equal to E. Identity element. But in this case, for multiplication, which is the identity element? That is your 1, right? So either you can equate A into B is equal to 1 or B into A is equal to 1. So जुन चाहिँ equate गर्दा पनि हुन्छ, which implies that A into B is equal to 1, which implies that B is equal to 1 upon A, which also belongs to the set of real numbers. Or you may write B is equal to A to the power minus 1. So what is this A inverse? This A inverse is the inverse of A for multiplication. So therefore, A inverse is the inverse of A. So that is your answer. So I think you have understood this example. So you can copy it. Now we will do problems from the book. Okay, from the book of R.S. Agrawal. So we can copy it. So अघि मैले यहाँ प्लस साइन लेखेको छु, यो मल्टिप्लिकेसन हुन्छ ल, यो प्लस साइन हैन, यो के साइन हो, मल्टिप्लिकेसन साइन. ओके, दिस विल बी योर मल्टिप्लिकेसन साइन. So now we will do problems from the book. So now we will do problems from this book, Senior Secondary School Mathematics for Class 12 by R.S. Agrawal. Okay, so let us do exercise 3A. So let us do some questions from here. So now let's do this exercise 3A. Exercise 3A, that is your page number. This is RF 60. RF 60 from this book, Senior Secondary School Mathematics for Class 12 by R.S. Agrawal. Okay, so let us do this question number 1. So that you have to show that number 1 is star on Z plus defined by A star B is equal to AB is a binary operation. Is a binary operation. Okay, so now let us show that this star operation on Z plus. What is the meaning of Z plus? Z plus means it is the set of positive integers defined by A star B is equal to AB. This A star B is defined as AB. Okay, it is a binary operation. You have to prove that this A star B is equal to AB is a binary operation. Okay, so now here it is given that here given A star B is equal to AB. That means this A belongs to the set of positive integers. So here A belongs to Z plus and also B belongs to Z plus. So this A star B is equal to AB also belongs to Z plus, isn't it? So if you have A is positive integer, if you take A as a positive integer, B also as a positive integer, so A into B is also a positive integer, right? So therefore A star B is equal to AB also belongs to positive integer, because positive integer into positive integer is positive integer. You know that. Plus 2 into plus 3 is plus 6, isn't it? That means A into B also belongs to Z plus. That is your positive integer. So hence star is a binary operation. Hence star is a binary operation. So it is proved. Okay, so that is the definition of binary operation, isn't it? If A belongs to Z plus and B belongs to Z plus, then A star B is equal to AB should belongs to Z plus. So star here, this operation star is a binary operation. So this is the method. So how to show that star is a binary operation. So we'll do the next problem now. So now we'll do the next question, that is question number 1. Number 2, you have to show that this star operation on Z plus defined by A star B is equal to, this is modulus. Modulus of A minus B is not a binary operation. So you have to prove it. Okay. So you know that A belongs to Z plus. Okay. So A belongs to Z plus. You may write A star A here also. So therefore A star A is equal to within mod. So instead of B also you write A. So A minus A is equal to 0. So this 0 does not belong to the positive integer. So 0 does not belong to positive integer. So 0 does not belong to positive integer. You 0 is a positive number hoina. 0 is neither positive nor negative. So 0 does not belong to positive integer. So hence star is not a binary operation. Is not a binary operation. Is that clear now? So in this case, Z plus is the set of positive integer. Since A belongs to the set of positive integer, so if you write A star A is equal to within mod, it will be A minus A, which is equal to within mod 0 means that is 0, which does not belong to the set of positive integers. So hence this operation star is not a binary operation. Okay, so you can copy it. Now we'll do the next question now. So now we'll do the next question, that is number 3. You have to show that this operation star on Z. Z is a set of positive integers. Not positive integers, not only positive integers. Here star on Z means Z is any integer. It may be positive integer, it may be negative integer, including 0 also. Okay? Star on Z only means यदि यहाँ Z plus देखो बात set of positive integers, Z here minus देखो set of negative integers. Okay, but only Z is given out here. So this Z is the set of integers. It may be positive integers, it may be negative integers, including 0. Okay, so it is defined by A star B is equal to A minus B is a binary operation. You have to prove that this star is a binary operation. Now here given is A star B is equal to A minus B. Okay, and now in this case A belongs to Z and B belongs to Z. Both these A and B belongs to the set of integers. So therefore A star B is equal to A minus B also belongs to the set of integers. That is, difference of two integers is also an integer. We know that difference of these two integers is also an integer. That means A star B is equal to A minus B also belongs to the set of integers. So hence star is a binary operation. Hence star is a binary operation in this case. So here star is a binary operation. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is number 4. You have to show that this operation star on Q. What is Q here? Q is the set of rational numbers. Q is the set of rational numbers. Q is the set of what? Rational numbers. So what is rational number? You know that a number of the form P by Q, where Q not equal to 0 and P and Q are prime to each other. That means they should not have common factors among P and Q. So this type of number P and Q is known as rational numbers. You know that, isn't it? I told you I told you about rational numbers in class 11 while doing mathematical reasoning, right? So a number of the form P by Q, where Q not equal to 0 and P and Q are prime to each other, are known as rational numbers. Okay, so here star on the set of rational numbers defined by A star B is equal to AB by 2 is a binary operation, right? So here given here is this star is defined as A star B is equal to, this is your AB by 2. So you know that this, if A belongs to Q, here A belongs to Q, here A belongs to Q and B belongs to Q. If A belongs to Q and B belongs to Q, so naturally this A star B is equal to AB by 2 also belongs to the set of rational numbers, right? So therefore A star B is equal to AB by 2 also belongs to the set of rational numbers. So hence star is a binary operation. Hence star is a binary operation. Hence star is a binary operation. So it is proved. So I think you have understood it. So now we'll do the next question. So now let's do this question now. That is question number 1, number 5. You have to prove that star on real number, R means real number, defined by A star B is equal to AB square is a binary operation. You have to prove that A star B is equal to AB square is a binary operation. Okay. So now here given is A star B is equal to AB square. Now, if A belongs to the real number, now therefore here A belongs to real number, A belongs to real number. Okay. Now, B also belongs to real number implies that B square also belongs to the real number. Okay. So if B belongs to real number, it implies that B square also belongs to the real number. Is that clear? So therefore we can say that this A into B square, that is AB square, that is if A belongs to real number and B square belongs to real number, then AB square also belongs to the real number. So hence we can say that this star defined by A star B is equal to AB square is a binary operation. So we have proved that if A belongs to real number, now B belongs to real number implies that B square belongs to the real number. So AB square also belongs to the real number. So hence star on R is a binary operation. Is a binary operation. So it is proved. So I think you have understood it. So you can copy it. So this much is for today. त आज हामीले जति पनि गर्यौं यो जति पनि डेफिनेसनहरु मैले जुन चाहिँ एक्जाम्पलहरु दिए यो सबै तिमीले घरमा एकपल्ट राम्रोसँग हेर्नु, यसलाई बुझ्ने चेष्टा गर्नु अनि यो जुन चाहिँ हामीले 5 वटा अहिले भर्खर प्रब्लम गर्यौं त्यो पनि घरमा तिमीले राम्रोसँग हेर्ने अनि यसलाई पनि बुझ्ने चेष्टा गर्नु. So in the next online class, we will do more problems on this chapter, that is your binary operation. So this much is for today.